Welcome to SS2 Computer Science, Term 3, Week 18. This is your comprehensive mock WAEC examination, a full practice paper covering the entire SS2 Computer Science curriculum. This mock exam simulates the actual WAEC format and difficulty. Work through each question carefully, showing all working for calculations, and write clear, precise answers. By completing this mock exam, you will consolidate your knowledge, identify gaps, and build examination confidence. Let us begin. Mock WAEC Section A, Objective Style Questions with Answers, Q1. Which of the following is an example of secondary storage? A. RAM. B. CPU. C. Hard disk drive. D. Cache memory. Answer: C. Hard disk drive, persistent, holds data without power. Q2. In binary, what is 1101 plus 1010? A. 10110, B. 10111, C. 11001, D. 11,000. Working: 1101 plus 1010, 1 plus 0 is equal to 1, 0 plus 1 is equal to 1, 1 plus 0 is equal to 1, 1 plus 1 is equal to 10. Result: 10111. Answer: B. 10111. Q3. Which sorting algorithm has the best guaranteed worst-case time complexity? A. Bubble sort. B. Quick sort. C. Merge sort. D. Selection sort. Answer: C. Merge sort. O. N log n, guaranteed in all cases. Q4. In OOP, the ability of objects of different classes to respond to the same method call refers to A. Encapsulation. B. Inheritance. C. Polymorphism. D. Abstraction. Answer: C. Polymorphism. Q5. Which SQL clause filters groups after group by? A. Where. B. Order by. C. Having. D. Distinct. Answer: C. Having. Q6. A firewall operates by A. Encrypting all data. B. Monitoring and filtering network traffic based on rules. C. Compressing data for faster transmission. And D. Translating domain names to IP addresses. Answer: B. Monitoring and filtering based on rules. Q7. Which of the following is not a characteristic of cloud computing, NIST? A. On-demand self-service. B. Vendor lock-in. C. Resource pooling. D. Measured service. Answer: B. Vendor lock-in. This is a disadvantage, not a defining characteristic. Q8. The process of organizing a database to eliminate redundancy is called A. Indexing. B. Normalization. C. Replication. D. Partitioning. Answer: B. Normalization. Mock WAEC Section B. Theory questions. Question 1. A. Distinguish between a compiler and an interpreter. 6 marks. Compiler translates entire source code into machine code in one go before execution, produces a standalone executable file, fast execution, no runtime translation, errors reported for entire program at once. Examples: C, C++, Pascal. Interpreter translates and executes source code line by line at runtime, no executable file produced, slower execution, translates each time, stops at first error, better for interactive development. Examples: Python, PHP, JavaScript, traditionally. B. Write an algorithm in pseudocode that accepts 10 numbers and outputs the sum and average. 6 marks. Begin. Total equals 0, count equals 0, while count less than 10 do. Input number, total equals total plus number, count equals count plus 1, and while, average equals total / 10, output sum equals plus total, output average equals plus average, end. C. Trace the following code and state the output: n equals 1, result equals 1, while n equals 5, result equals result times n equals n plus 1, and while, output result. 5 marks. N equals 1, result equals 1, iter 1, result equals 1 times 1 equals 1, n equals 2, iter 2, result equals 1 times 2 equals 2, n equals 3, iter 3, result equals 2 times 3 equals 6, n equals 4, iter 4, result equals 6 times 4 equals 24, n equals 5, iter 5, result equals 24 times 5 equals 120, n equals 6, n equals 6, 5 loop ends, output, 120. This is 5 equals 120, the factorial of 5. Mock WAEC Section B, continued question 2, A. Given the following relation, student course, student ID, student name, course ID, course name, grade. Identify violations and convert to 3 nanofarads, showing each step. 10 marks. Step 1, check 1 nanofarad, all attributes appear atomic, no repeating groups, primary keys, student ID, course ID, composite, 1 nanofarad satisfied. Step 2, check 2 nanofarads, partial dependencies. Student name depends only on student ID, not on course ID, partial dependency violates 2 nanofarads, course name depends only on course ID, partial dependency violates 2 nanofarads. Fix 2 nanofarads, split into 3 tables: students, student ID PK, student name, courses, course ID PK, course name, enrollments, student ID FK, course ID FK, grade, composite PK. Step 3, check 3 nanofarads, are there transitive dependencies? No, in each table, all non-key attributes depend only on the primary key, 3 nanofarads satisfied. Final tables, students, student ID, student name, courses, course ID, course name, enrollments, student ID, course ID, grade. B. Write SQL to find the number of students enrolled in each course, showing only courses with more than 20 students, ordered by enrollment count descending. 6 marks. Select C. Course name, count, A. Student ID, AS enrollment count from courses C. Inner join enrollments E on C. Course ID equals E. Course ID group by C. Course name having count, E. Student ID, greater than 20 order by enrollment count desk. Question 3, A. Draw and label a simple network diagram showing 3 client computers, 1 switch, 1 router, 1 server, connection to the internet. 8 marks, also connected to, description of each component's function as labeled in diagram. B. Explain the OSI model 7 layers in order from bottom to top. 7 marks. Layer 1, physical, transmits raw bits over physical medium, cables, radio waves. Layer 2, data link, error detection, MAC addresses, frame delivery within same network. Layer 3, network, routing between networks, IP addresses. Layer 4, transport, end-to-end communication, TCP, reliable /UDP, faster, unreliable, port numbers. Layer 5, session, manages sessions / connections between applications. Layer 6, presentation, data formatting, encryption, compression. Layer 7, application, user-facing protocols, HTTP, FTP, SMTP, DNS, SSH. Mock WAEC Section C, Advanced and Contemporary Topics. Question 4, A. Explain what is meant by machine learning and give 2 applications relevant to Nigeria. 6 marks. Machine learning, a subset of AI where computer systems learn from data and improve performance on tasks without being explicitly programmed with rules. Algorithms identify patterns in training data and use those patterns to make predictions or decisions on new data. Applications in Nigeria: agricultural disease detection, ML models, e.g. Plant Village, allow farmers to photograph crops and receive AI diagnosis of diseases on their phones. Fraud detection in financial services, companies like Flutterwave use ML to detect unusual transaction patterns and block fraudulent payments in real time. B. Distinguish between supervised and unsupervised learning, giving 1 example of each. 6 marks. Supervised learning, algorithm trained on labeled data where each example includes the input and correct output, learns to map inputs to correct outputs. Example, spam email classification, emails labeled spam/not spam, algorithm learns which features indicate spam. Unsupervised learning, algorithm finds patterns in unlabeled data without predefined categories. Example, customer segmentation, group customers into similar segments based on purchasing behavior without predefined groups. C. Explain SQL injection and state 2 ways to prevent it. 6. Mark SQL injection, an attack where a malicious user inserts SQL code into an input field, such as a login form, to manipulate the database query, can bypass authentication, steal data, or destroy tables. Example, entering or 1 equals 1 into a username field bypasses the password check. Prevention, parameterized queries, prepared statements, use placeholders in the query, user input is passed as data, not code, the SQL structure cannot be changed by the input, principle of least privilege, the database user used by the web application should have only the minimum permissions needed, cannot drop table if the user has only select permission. Mock WAEC completed. Final examination advice for WAEC Computer Science, overall approach, read the entire paper before starting, identify which questions you know best, answer those first to build confidence, then tackle the harder questions. Calculations, always show working, binary conversions, number-based arithmetic, algorithm traces, a wrong final answer with correct working may still earn method marks. Definitions, learn precise definitions, WAEC expects specific technical terms, do not give vague or circular definitions. Algorithms, trace carefully step by step, write down variable values at each step, do not skip, examiners check every step. SQL, check join and on conditions, check where versus having, test queries mentally with small data. OOP, state all 4 principles by name with precise definitions, give examples. Data structures, know the key property of each, LIFO for stack, FIFO for queue, and typical applications. Networking, memorize the 7 OSI layers in order, know hop versus switch versus router functions. Security, SQL injection prevention, parameterized queries, and XSS prevention, output encoding, must be stated precisely. Complexity, memorize BIGO for key algorithms, state them as O, N superscript 2, O, N log N, O, log N, O, 1. Cloud computing, IaaS, PaaS, SaaS, know the boundary of what each model manages. Final checklist before WAEC, number systems conversions, algorithm writing and tracing, SQL join and group by, OOP 4 principles, data structures, stack, queue, linked list, sorting algorithms, bubble, quick, merge sort, searching algorithms, linear, binary, BIGO notation, computer networks, OSI, LAN/1, devices, database normalization, 1 nanofarad, 2 nanofarads, 3 nanofarads, cybersecurity, SQL injection, XSS, firewall, VPN, cloud computing, IaaS/PaaS/SaaS, AI and machine learning basics. Good luck in your WAEC examination.